All right. Good morning, good afternoon. It is time to start Unit 4. So we have Unit 4 and 5 left, and we have Quarter 4 left. So Quarter 4 will be kind of divided in half between our two largest units of Unit 4 and Unit 5. So Unit 4 is all about design, how things get designed the way that they are, what makes up design, what type of principles and elements we have to think of, the criteria, the constraints, and we are also going to fully focus on the engineering design process with that. So first thing is we are covering our first set of notes today through this Edpuzzle. So if you go into Haiku, you now have access to Unit 4. You'll notice there's not very much stuff in this today because we're just covering those notes, and then the second half of class, you're going to be doing something else. So in here, Unit 4 notes, principles and elements of design PowerPoint, open that up. This is just like we were in class, but obviously I'm not there, so you are having to fill in your PowerPoint as I'm going through it. So you're gonna have to split screen between your Edpuzzle and the PowerPoint because you will have to turn in this completed PowerPoint to me at the end. There's not a separate assignment today for it. Instead, I just want you to turn in the completed PowerPoint because it's that important that you have it completed and stored. Next week, we'll be doing a 3-day mini project with this, and you must have that PowerPoint to refer back to. All right, so once you have it open and split, let's get started. So we're looking at design, the design principles, and then the principles and elements of design, which are actually different than design principles. So first, let's just start with the unit big idea. So in Unit 4, the engineering design process is a systematic, iterative problem-solving method which produces solutions to meet humans' wants and desires. This is what we kind of have been doing the whole time with our engineering design process, but now we're actually learning all of those steps and learning what they mean. This is our definition for it. We will cover this more next week when we get into the actual engineering design process and learning them. But for right now, this is just our unit big idea. The lesson big idea. So specifically for today, engineers and designers must incorporate design principles when generating solutions to problems. So we are looking at those design principles. When an engineer or designer is given a problem, they must utilize these in order to solve that problem, whether it's thinking about ergonomics, whether it's thinking about different people's capabilities, how a product actually looks or functions, or anything like that. So design itself. Design, why we have design, they solve problems for engineers, architects, and designers. It's helping us to solve any sort of problem. And in order to do that, we use scientific knowledge and mathematical applications. So we've kind of already done that in Unit 3. We learned mechanical advantage and Ohm's law. Those are your scientific knowledge, but they also have the mathematical applications within the formulas. And we use that to help electricians for Ohm's law figure out the voltage and the current and everything needed. Or in mechanical advantage for construction or different mechanical engineers to figure out exactly how we can help a person do something using those mechanical constraints. All right, so design requires taking constraints into account. So constraints, we've talked about it a few times, but remember, constraints are your limitations. So we're talking about physical, biological, economic, political, social, ethical, and aesthetic. So physical, what physical constraints does somebody have? Are they in a wheelchair? Do you have a cane? Do you have no physical constraints? It just all depends. The strength of somebody. Biological, so what actual biological constraints do you have if you have a sickness or disease or you're just not feeling well? Economic, with money, any money constraints that people may have. Political, social, so social if some people don't like public speaking, so that would be considered a social constraint. Ethical, we're talking about morals, and then aesthetics is what we're going to be focusing on today in a little bit with how something looks. All right, so sticking with design, a designer has to have certain personal characteristics in order to be successful. So they must be creative. If you're not creative, then it's hard to think up new ideas. So in order to be a designer that's designing brand new products in construction, you have to have that creativity. Resourcefulness, be willing to look things up, not just be lazy and sit there and stare at a computer if you can't think of an idea. You want to be resourceful, look things up, figure out what else is out in the world, and how can you build off of that. You want to be able to visualize and then also think abstractly. So that all kind of ties in with creativity, but we want to visualize things and then think in a different way than others. And then you also have to take into account human values and limitations. So that kind of goes along with the ethical constraints. So design principles. There are 4 main design principles, and these are used to create design across all technologies and evaluate those designs. So this is how a designer, architect, engineer, anybody looks at things based on the flexibility, balance, function, and proportion. So flexibility is just the material properties or flexibility related to the purpose of the object. So if I had a alarm clock, can it also play the radio? So the flexibility of that object, the purpose, it can do more than one thing. Balance, so how well the elements within the product are in relation to one another, the position of those. Function, we know what function means, it's just the purpose of the object. And the proportion, so the size elements, how are they related to one another? So there is a universal design, which means that all new environments and products should ideally be able to be used by everyone, regardless of age, ability, or circumstance. So this is ideal for every product. Obviously, not every product follows these guidelines, but this is what at the beginning a designer has to think of and has to try to follow, so that no matter if you're 80 or 8, you'd be able to use the product. No matter what your physical, mental, biological ability is, you're able to use the product. No matter what circumstance you're in, you're able to use the product. And again, this is doesn't always come into play where, somebody that is 80 might not be able to play with a toy rocket the same that, I'm sorry, that was a bad example. Somebody that is 80 may not be able to run and catch a football the same that somebody that's 8 is, but they could if they had that physical ability. All right, so within a product, we have different design considerations. So you want to think about the design as the result of a formal sequential process. So by the end of the design process, which we're going to learn next week, you have a product, and that is the product of that process. So it's an engineering design process is very formal, it's sequential, you have to go in order, and then you end with a product. Design problems seldomly arise in a clearly designed form. So it's not usually black and white where, all right, this is the problem, fix it. Usually you have to kind of research into different problems. All right, well, if we don't have clean drinking water, why don't we have clean drinking water? Is it because the pipes are rusted and it's getting into the water in the piping system and the plumbing system? Is it because there's contamination in the lake? Is it because what is the reason? So there's a lot of different reasons for different things. So you have to figure out the problem first before you can solve it. Design is driven by profit, motive, and market. So just like everything else we've talked about, money is a big situation with design and engineering. Design requirements sometimes compete with each other. So again, we've talked about this before as far as trade-offs. So you have to choose the best trade-off. Design is the result of a goal-oriented research. So you start with a goal in mind, research it, and end with something. So that goes back to our research and development. And then design must be continually checked, refined, and improved. And this is a huge one. This is what a lot of this class is based off of. Nothing is perfect. There's always room for improvements. So as you have a technology design, you have to make sure that you come back and always continue to improve that technology. All right, so those are our main overall design. So in the next Edpuzzle, we're going to talk about the principles and elements of those design. And that will continue with your PowerPoint.